Okay, what is Numpy? So Numpy stands for numeric byte. So numeric, any numeric operation we can use Numpy for getting high performance scientific computing and data analysis in Python. Okay, so Numpy is a numeric related activities. Anything we can do with Numpy. Okay, everything is array oriented. Here, array oriented. Array in the sense is a matrix. We are handling the 2 by 2 array, right? 3 by 3 array. It's a two dimensional array. Everything is array oriented computing. So we handle multiple dimension arrays with the NumPy, the scientific computation, everything. Because of this development, after getting a NumPy packages, then only the people using they can easily do the computation. They don't dig into the formulas. They don't need think about the formula. Everything NumPy packages will do this one. Okay. So the transformation, the Fourier transformation. Fourier transformation is nothing but some signal waves is getting transformed into some other function. Okay. So we can handle all the things and linear algebra and random number generation. So NumPy package are helping to do all these things. Mainly thing is numerical operation and scientific computation. So we can do with the NumPy. Okay, here for the data, we have a different kind of data. Everything is array oriented computing. How arrays are working here? What is array? So we have a list. We have seen list in Python. Okay, that is array. Okay, if we have a list like this, 1, 2, 3, we are having it's a one dimension array. Okay, so one dimension array. We are having one dimensional array. If you have a two axis, a row and a column, row and a column, if you have a two axis, that is two dimensional array. Is kind matrix here. Okay, matrix. It has a list of list. You have a list inside list. You have another list. So that is called two dimensional array. It has a row, x axis and y axis, row and column. One more, if you have a depth, okay, the axis is a kind of a cube. Okay, if you have a this kind of data, three dimension, that is called three dimension. Beyond this, we can't visualize for our human eyes. So that is n dimensional array. Normally Python can handle n dimensional array, multiple dimension. Only we can visualize till three dimension, but after that we can't visualize the data. So but machine will understand all the things. Okay, so that is everything is a dimension. Okay, array oriented. So everything is multiple dimension array can NumPy can handle those data. Okay, and next thing is how to import. After installing the packages, we have to import wherever we want. Which if we want to implement, if you want to use NumPy, we have to import load NumPy packages. So for that, we can use import NumPy as you can give any name. Normally, people use NP. Import NumPy as alias name is NP. Suppose it is if it is not getting installed, you can install exclamation pip install NumPy like this through Jupyter Notebook. Also, you can install. Okay, so various ways are there to install. Okay. So like this, you can install. After that, how to create a simple NumPy array. Okay, we have a list, but we have to create it. It in create NumPy array. How to create? Just you can use in NumPy there is array function. Okay, if you use np dot array, so NumPy array is getting created. Okay, this is the output is like this array of these elements. So you can create. So now we will see how to create. If you want to check the array, you can use in type. You can use is a common Python function type. You can use NumPy dot n dimensional array like this. So you want to check how much how many dimension it has. Okay, you can see n dim. You can check my underscore array dot n dimension. You can use this uh, attributes to check the dimension. This dimension is normally in programming it comes like this, but in default always like this. Okay, 2, 4, 6, 8, 10. Okay, so one column, how many rows? 5 rows. Okay, it has a 5 rows and one column. Normally, arrays matrix should be like this one. Okay. Okay. What is the size? Okay. If you want to check a size, it will give the size. And if you want to check shape, how many rows and how many columns? Okay. 5 rows. Default is 1. That's why it doesn't have 5 rows. It has whatever I shown here, right? It has a 5 rows. 5 rows. And the second parameter is column. It's the default one. So that's why it doesn't have that number. Rows and columns. It should be in a rows and column, this format, shape. So n dimension, if you want to check dimension, you can use array numpy array dot n dimension. Yes. So n dimension, and you can check size of the array, size of the number of elements, number of items in the array it gives, and shape. You can check the shape, what shape it is. Okay. So from a Python list, how to create array. So this one is a list. If you check, this one is a normal list. Already we have seen Python list. So if you check the type of that object, it gives the list. If you want to convert into NumPy array, you have to use np.array. You have to pass parameter as a list. List as a parameter. You have to pass a list in the parameters. So it is getting converted. If you check the type, it will give the numpy.n dimension array. Okay. What are the different ways you can create? Or you can use like a range. We have seen range function like in array range. So a range, it creates some array. NumPy, if you we have seen range in the list, but here you have to use a range array range. So if you give only one number, start with 0 till 9, it's create that array. Suppose if you have a start and n number, if you have a step size, you can create array with that. Anyway, you have to use np dot arrange. Instead of range, already we have seen range function. Similar to here NumPy, we have a range. And there is a line space. What is the line space? Line space. You have a start and the end value. Between that value, you have to create a 5 values with equal space. Okay, between 2 and 10, you are creating 5 space, line space. 5. You are in this program creates 5 numbers with the equal space. The difference between two numbers, the consecutive numbers differences are same. So equal space. With the equal space, they are creating 5 numbers. So line space. And so np.once, numpy.once, it creates all elements is 1. Okay. Default, if you see here, default is a float values. 1 dot, it's creating 1 dot. So default is float values. If you create any items, the default is float values, float items are getting created. If you create a 0, all elements are 0. Ones mean all items are 1, zeros means all items are 0 here. Okay. So why we use NumPy array instead of Python list? Already we have a Python list. Okay, it's a NumPy array gives works in efficient way in memory. Okay, so we are going to handle multiple numeric operation. Right, the performance is faster with the NumPy compared to list. So there is a one difference you can see. We have a list here. We have a list range. It has a 0 to 1000, 0 to 999. 1000 numbers are there in this list. We are creating a square of all the numbers. Okay, 1000 numbers. So 1000 times it's getting executed. Okay, we are creating one more list. We will check how much time it takes. We will see now. Okay, if you execute this. So okay, 614 microsecond. Okay, so if you here we are using NumPy array. Okay, it's also having 1000 number. The same thing we are having. We are squaring all the values. So 614 microseconds, here only 3.24 microseconds. You see the difference, right? The time taken, the efficient way, and the operation, everything is uh, compared to normal list. NumPy is handling a much more efficient way. Okay, so the performance is faster. That's why we are using NumPy for computation. Okay, what are the different data types we can use NumPy? Okay, suppose it's a default is a float one, but if you assign any value, integer values, you can use integer. Okay, and if you want to check item size, one more, we have seen size. Size means is the number of items in the size. Item size, the memory use of each array elements in bytes. Okay, that is called item size. The memory, the bytes, how much it's each item is getting used. Okay, 4 bytes. So that is the item size. If you want to see what are the different attributes NumPy has, okay, you can use the dir method. This is a inbuilt Python function. You can use that. You can list out it will list out all the attributes what NumPy has. Okay, so all any most of the things are common in Python function also has the same thing, but you can see what are the things. Suppose if you are handling the number, you want to check what are it has this one or that one. You can use the dir method. Wherever you want, you can check whether it has or not. What are the attributes it has? Okay, like this you can see that one. And so float, we are handling float here. Okay, if you anything a float value you can give. Okay, and default is a float. Okay, whenever you are creating ones or anything, it will create a float value. Suppose you have this one. So for avoid, there is you can use pass two parameters in the numpy array of when creating a numpy. In array function you can pass two parameters. First parameter is what are the items it has. Second parameters you can pass as optional parameters. You can pass what is the DT type. So you can give the type of what type you want to create array. Okay, data type. You can pass two parameters. Okay, this one is compulsory. You have to pass this mandatory parameters. This one is an optional parameter. You can change the data type. So whenever we are handling the collection object more than one item, we have to we for accessing the data we have to use indexing. Okay, in NumPy also all the items has the index value. Okay, based on the index we can get the retrieve the items. Okay, here we are creating a random number, 10 random numbers. Okay, for that number is so random generation, random number generation. NumPy is working smartly for creating the random numbers. Okay, I am creating 10 random numbers. Okay, for that it start with the index value, start with 0. Okay, this first item has a similar to list and tuple. The first item start 1 2 like this. It has some index. If you have if you know the value of array object, numpy object, you can access any elements with the index. Okay, so you can so the positive index like this. We have a negative index start with -1. So everything is similar to list. Sorry. So we can create a negative index like this. So we can mask. We can create masking index. Okay, how to create in step 0 1. I want to mask that index. So here we are creating a random integer 1 to 20. Low number is 1, max number is 20. In between this 10 numbers, 10 random numbers. If you give line space is a different. Line spaces it create a equal space a number, 10 numbers with the equal space between 1 and 20. But here random number, any random number. So we created some random numbers here. Okay, we have to index all even numbers. So we have to index for all even numbers. in the array using Boolean mask. For that, we are setting up some how to identify the even numbers. So if anything divided by 0, mod is 0, it gives the even numbers. Okay. So we are setting some index here. So Boolean mask index. So it returns even numbers. Okay. If you observe the code, right, if you see, right, my array colon to see my array is this object. So percentage 2 is equal to 0 means it gives some index. Index has true or false. Okay. True or false. So index is Boolean mask, index is set with Boolean values, true or false. Okay, how they are doing this index in the index? So we are using this one is a mask, Boolean mask. If you assign anything here, based on the condition, the index is getting set. Okay, that is called Boolean mask. The similar way you can set it. Suppose for integer, if you want to set it for integer mask, you can do this one, integer mask. Simple thing is, inside the array we are setting up some condition. Okay, that's it. Here integer mask, we have a list of integer, so random integers. So we are having inside this mask, right, what is the condition here? We are creating 1 to 10 numbers, step size 2. 1 to 10, we are okay. My array, inside this one, whatever we want to select, right, we have to give so what is the index? We have to give index. If you give the index, the item is getting returned here. Okay, for this, what we are doing is we are setting some range function 1 to 10, step size is 2. So 1 to 10 step size is 2 means what is it? It will print 1. Step size is 2 means 3 goes to 3, 5, 7. So first index, this one is 0, 1, 2, 3, 4, 5, 6, 7, like this. Okay, so it will return first. Okay, and third. Okay, fourth, fourth in the sense fifth and seventh and ninth. So everything is given. So we are masking the index. Okay, we are putting some mask here. So based on the mask output, it return the result. Okay, so that is the integer mask and Boolean mask. So how to slice? The slicing operators, everything is similar to list. Okay, so we will see here. Here we have a Numpy array object. So we are slicing. So slice means it has a splitted in colon. Start parameters, end parameters. Okay, start and end. Okay. Here starters we didn't give any value, so it takes all uh, start with 0. Okay, end is 2, 0, 1, 2. Before that, it will stop here. So return 14 and 19. Okay, similar to minus 3. Minus 3 means from here minus 1, minus 2, minus 3. Start with 5 and end is all. Okay, till end. 5, 13, 3. It is getting returned. So through negative index. So slicing we can do similar to list, already we have seen. So what are the basic mathematic operation we can do with NumPy? Okay, we'll see. So if you want to see a summation, so we can use it, because suppose if you want to sum in list, how to do this sum? We have to create some lambda function or some function. We have to iterate all the elements and creating list. Okay, anyway, we have to use some function, but here NumPy, simply you can create a dot sum or square root. After passing the parameters, after passing the array in this parameter, it creates sum. Okay, in single line you can do this one, square root, log, and exponent values. You can create this with a single. So NumPy is a scientific computation, right? So everything we can do. Till now, what we have seen is a single dimension. Okay, it looks very simple, but if you handle multiple, more than one dimension, how to handle here? So 2D and 3D arrays, we can handle it, and so How to create a 2D array? What is a 2D array? If you have a list, single list, that is a one-dimensional array. If you have a list of list, this is, there is some list here, there is some list here. If you have this kind of list, it's a two-dimensional array. Here we are passing list of list in numpy array. It creates a two-dimensional array. Two-dimensional array is nothing but matrix, like here 2 cross 3 matrix, 2 rows and 3 columns. Okay, so we have seen a matrix in our schooling days, right? It's a two-dimensional matrix. Okay, here if you want to check a dimension, you can see dimension and the shape. Shape is two rows and three columns. So first element is a row, second element is column. Because wherever we are using in this shape, right, it always gives first is a row, second is a column. Okay, is a differ. If you use a 3 dimension, it will be changing. Okay, I will explain later. So if you the same similar to one dimension, here also you can create ones, number of ones. You can create all the item elements or values are one. You can use, if you use numpy dot ones, numpy dot zero means all the items values are zero. If you want to create other than one, if you want to create any specific values, you can use it np dot full. Okay, every all values are, we are passing two value here, so everything is created with value 2. And 3 cross 3 default empty. You want to create a empty numpy dot empty, you are creating empty matrix here. So 3 cross 3 matrix. So diagonal elements, if you want to create a diagonal elements, all elements are one, means you can use I. Okay, we have seen np dot 1, np dot is, np dot full, np dot 0. So various ways you can create matrices here. So default matrices. So list of list is 2 dimension, list of list is 3 dimension. 3 dimension is it has a one more dimension other than row and column. It has some page, or you can use call it as some depth. It has some depth. Okay, here also you have a data. This first example, this one is a 3 dimension. So here you, this one is a page 1, page 2, page 3. That's the depth element. So we have a 3 pages. Okay, how many rows it has? 1, 2, 3, 3 rows. How many columns? 3 columns. So this shape is 3 pages, 3 rows, 3 columns. So we can identify with 3 cross 3. So in 3 dimension, so if you check a dimension, it gives a 3 because it's a 3 dimension. If you see shape, okay, here in this it has a 2 pages, page 1, page 2. Okay, page 1 and page 2. It has a 2, 4, 6, 8, 10, 12. Another one is 1, 2, 3, like this. Okay, page 1. That's why first parameter is 2. It has a 2 rows and 3 columns. Okay, 3 columns. That's why shape is like the similar way for 2D and 1D. We can create we can use ones and zeros for creating this one. The slicing operators is here also same. You can use the slice operator, but you have to think how 1.1 we have to slice. First parameter is always rows, second parameter is column if you slice anything. So 1 comma 1, 1, this one is a 0th row, first row. Okay, first row, this one is the first row, column is 1, 0th column, first column. So if you cross here, this value is getting printed. So how to get the excessive values in the 2-dimensional or 3-dimensional array. Slice the last 3 columns. How to slice last 3 columns? Here In this one, you are having two parameters. First parameter is simply colon. Second parameter is 1:3. 1:3. First parameter is this one is for selecting rows. This one is for selecting columns. Okay. First one is entire. We are taking a row, so entire row is getting selected. And columns we are selecting 1 to 3rd. So all the column, all the rows, we are selecting all the rows. All the rows. Column is 1 to 3. This one is 0, 1, 2, 3 means before that. Okay. So 1, 2. So we are, these portions are getting sliced out. See here. So this one is in many places in case studies and building algorithm, we will use this slicing part. Not only here in Pandas, we will use this slicing in many areas for selecting columns and rows. This is very important. And if you see the here, right, 0 to 2, row is selecting 0 to 2, column is 0 to 2. You can easily understand this.